So our first step is angle 2 is congruent to angle 3. That's given. Hopefully we got that down. And then Jacob said, note that we have vertical angles. All right, so even if I'm not sure what to do in a proof, even if I had no idea where I was trying to go, you should have at least noticed there's vertical angles. All right, and if you didn't, we got to practice that, the vertical angle thing. All right, we have to be able to see that. Because even if I can't do this proof, your job, if you can't do this, is A, to list why it's true, or B, just list all the things you know are true and just say, I don't know where to go from there. All right? So even if you had no idea how to do this proof, you should have at the very least said that these two are congruent. These two are congruent because they are vertical angles. All right, so let's just go ahead and do that. So I'm going to say angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. Well, I actually didn't need all that information, but it's always good to list as much as you can. I should put 1 here, 2 here. That's just a definition of vertical angles. Oh, did you have that, Sabrina? Yeah.
I put down definition of congruent. Is that the same thing, or?
It's not the same thing.
Oh, okay.
Has to be the definition of vertical angles. It is the only one I'll accept in that one because I'm using the fact that they're across from each other to say they're congruent. I agree that there's some kind of congruency thing happening, but you have to state that they're across from each other. You have to tell me why they're congruent. All right, that's it. That is honestly the only big step you have because step 3 is the answer. Step 3 is angle 1 is congruent to angle 4. Sabrina?
Substitution?
Substitution, yeah. Yeah, does someone else have something else?
I just have a question.
Oh, well, I don't answer questions in this class. Yeah.
I had that, but then I added other stuff because I thought I put like angle 1 is congruent to angle 3 because, and then angle 2 is congruent to angle 4 with like substitution. But then and then I didn't know what to put for angle 1 is congruent to angle 4. Would that be substitution as well?
Did you say angle 1 is congruent to angle 3?
Yeah. Because angle 2 is
Yeah. But it's kind of a useless step. I get what you're saying, but you're going way... So basically what you did is you took substitution, and you replaced this here, and then you jumped and put that there.
Yeah.
All right.
No, I put the 4, yeah.
So we went to an extra step. Yeah, you just went through kind of an extra step. Yeah.
Could you put something in with like the transitive property,
Yes.
like 1, 2, 3, and 4?
Yep, because you can go 2 equals 3, 3 equals 4, 1 equals 2, so transitive property is...
So then, would you go from the transitive property to number 4, would it be subtraction, or would it be like if number 3 was angle 1 is congruent to angle 2 is congruent to angle 3 is congruent to angle 4?
You could just jump and just go straight to your answer. You don't have to use any subtraction. The transitive property lets you not have to do any subtraction or anything. Yeah.
So like if I had like two reasons that were the same, like substitution property, then substitution property, probably one of them probably isn't needed.
Not always, right?
Always, sometimes.
But sometimes. And
Okay.
don't eliminate steps because you think it's too long,
Okay.
right? It's this, some of this stuff is too long. Like sometimes I'll put extra steps in here that could be eliminated. But I'd rather have too many steps here than not enough steps to support what I'm talking about. All right? So if you have 4 or 5 steps in here, because you did the whole transitive property, is it wrong? Absolutely not. All right? Don't change it because I just did it a different way. All right? Make sure it makes sense to you, though. Each of these proofs has to make sense to you, because if you're just copying down what I write every single day, you're not actually learning how to do proofs. All right? You'll never learn proofs just by copying down what I say. You have to be thinking ahead of where I'm going. You have to be thinking along your own lines of solving it. Okay? All right, questions on this one proof? Okay, then let's go to questions on the homework.
Could it be homework from 2 days ago, or just because we never checked that? Or did you go over that yesterday?
I went over it yesterday, but
Oh, you did?
does it? I'll preface it with: does anyone have questions on today's homework? And then if we have time, we'll go over homework questions from that one. Okay, Grace? Yeah.
Number 15.
Number 15? Oh, is that the proof one? That was, what, page 63 through 64. All right. Just a proof. Just a proof. And the first step is given, correct? And Sabrina, since you asked this question, what goes in this blank here?
Angle 3 and angle 5 are supplementary.
That's it? Yep. And remember, anytime we state something, we want to explain it to the reader. So without even looking at that, I bet you any money the next step is it describes what supplementary is, right? Without me even looking at it, do they talk about what supplementary means? Yes. They say this equals 180, this equals 180. That's just our definition of supplementary. Remember, worst case scenario, you're not sure if it's a theorem or a postulate, just put a definition down and you lose like maybe half a point or something, because I know what you're talking about. But we'll go with definition of supplementary. Or you could have did angle addition postulate. I've been okay with either one of those. Well, here they just took, well, they said if this equals 180 and this equals 180, I can just take this and put it on the other side. So they went ahead and used substitution. Then they used the reflexive property, just basically, this is one of those steps that you could possibly leave out and I wouldn't take points off of. Because I fully understand if you're just subtracting measure of angle 5 from both sides. So this reflexive property, know it. But if it got dropped from a proof, I wouldn't take points off for it, okay? So if you skip right to this one, I would know what you did. I would know that you used subtraction property of equality. Did you have a more specific question, or did that answer your questions?
Oh, I was just like a little bit because like I didn't really get like because I feel like number 1, like steps number 1 and number 2 were kind of the same thing.
They are the same thing. This is a statement. This is unpacking the statement. And that's what you're going to do in proofs. Okay, when I give a statement like complementary, your next step should be something with 90 degrees. All right? If I say, I don't know what else I would say. But we unpack the statement if we can. If this has a number in it, we'll come up with that number. So it is the same step. I agree with you. This is just unpacked version of it. Okay? Yes?
For that one, I also did, like for the fifth step, I put theorem 2.8 because like, you know that since like measure of angle 5 and measure of angle 5, like you could, was it, we're able to combine them with like the, and then have the reflexive property? Or is it just work better with subtraction?
Subtraction property.
Okay.
Just how it's set up. You could possibly set it up so the other one would work, but just the way this is set up that I subtract measure of angle 5 from both sides, it's set up perfectly for subtraction. Okay? I get what you're doing, but you'd have to like change a little bit and really stretch the meaning of stuff. Where subtraction is just a nice clean color. But that makes more sense too? Yeah.
Also, when I was checking the new answer key, I couldn't really find it. And I was wondering if that was because I use the Google Classroom on my phone. Is that like, would that be like a reason why?
That would be a reason why. All right. Other questions from this assignment? Yes.
For number 6, it said it was the angle addition postulate.
Is it wrong?
Oh no, I was just gonna ask a definition of.
Yeah,
Does that work too?
Oh, that was on the other sheet.
Oh, yeah.
Oh, okay.
Because I said both those generally work there. Because we are adding 2 angles, but you have to know what supplementary means. So in the book wants you to use angle addition, but doesn't it make sense that you have to say, you have to know what supplementary is? So I'm using something with supplementary, I'm using something with angle addition. So technically we're using both. Either one works. I'm okay with either one of those. Yeah, Amber.
Yeah, so then I did the exact same thing for number 2. I said definition of complementary instead of the angle addition postulate.
Gotcha.
Is that alright as well?
Yeah. Hey, on a test, if you're not sure, and you know it's between two things, why not just put both things down, right? Just in case. I'm not gonna take points off, but maybe one is more correct than the other. I mean, who knows? Okay. Other questions on the homework? I was gonna get to Grace's. Grace had a question on the one before. The homework before.
Oh no, I figured it out.
Oh, in that little bit of time. Awesome.
Well, yeah, it was like just like I think
Same
the way
kind
I
of.
did it worked.
Okay. Okay, good. Good. All right. You're going to notice that we already did this proof. You're going to do it again without looking at answer keys. And in fact, we're just going to do that. All right? We're going to work on that right now all by yourself. We've done it before, but we aren't going to look at the answer.
That angle 1 plus angle 2 equals 180 degrees.
So we unpack what supplementary means, right? So angle 1 plus angle 2,
And that's the definition of supplementary.
either definition of supplementary or angle addition postulate. Either one is fine. I'm just going to go with the angle addition postulate, but either one works there. All right, then we're going to notice that well, angle 2 equals something, but first we have to state it. We have to go ahead and state it. I guess I should have collected your homework anyway. So this is that step that you're missing. This is the one step you're missing. Is you dropped out on the measure of angle 2 equals 145.
Oh, okay.
Is it a crucial step? No. I wouldn't take any points off. You would have been fine. All right. And that's given as well. And then we're going to replace angle 2 with 145. So I have angle 1 plus 145 equals 180 degrees. That's just substitution. And finally, we're going to have, well, angle 1 equals 35 degrees. And that is going to be subtraction. Well, that's not an S.
Or combine like terms. Right?
Let's talk about that in a second, okay? Subtraction property of equality. It's not combining like terms if they're on the same side. So if I have x plus x and I make it 2x, we really don't have a good property to say. We can use distributive, but it's hard to picture distributive. So if it's on the same side and you're pushing things together, then it's combining like terms. If something's happening on both sides of an equation sign, we should be using a property of equality, either subtraction, addition, multiplication, or division. But I think it was, who was it that said, but I'm adding a negative, can I use the addition? That was, yeah, and I said, as long as you have that defense. Yes? No. No, you can.
That's what I thought.
You just have to tell me you have to go to the bathroom. You know you're missing something, but if you gotta go, you gotta go. All right, the next thing I have are two theorems. We did these theorems yesterday. We used these theorems before we even properly even learned them. All right?
They're on the sheet.
They're on the sheet. Did they make sense?
Yes. I thought we did learn
Kind of. We talked about them vaguely. I didn't put them down like this. I didn't put them down in a nice official capacity. We just talked about them. All right, so theorem 2.7 says if two angles are supplements of a congruent angle, or the same angle, then the two angles are congruent. Let's give a hard explanation of why this is true. Let's say 2 and 4 are congruent to each other. So let's say they're 20 degrees. And this one's 20 degrees. Now let's say angle 1 and angle 2 are supplementary. What does angle 1 have to be? Yeah, 160 degrees. Well, if 3 and 4 are supplementary, what does 3 have to be?
160 degrees?
160 also. That's what this theorem says. Test. We have tons of theorems, right? The last thing you want to do is come to a test with just a blank theorem sheet and hope you can go through all of them. All right, but that's what it says. If these two angles are congruent, and we have two other angles that are supplementary to them, those new two angles are also congruent. All right, that's all this says. All right, does that make sense?
we also say like angle 1 is congruent to angle 3? Is that?
Angle 1 is congruent to angle 3. Yes.
Yeah.
Yep. And theorem 2/8 is the same thing, just with complementary instead of supplementary. So when you're going to look out for this theorem is if I say two angles are complementary. Like if I say angle 2 is complementary to this angle, and this angle is complementary to this angle, you're going to immediately think 2, 7. All right, you see two complementaries in a row. All right, but that's all it says. Yes?
Do we have to use theorem 2.7, or can we kind of like do it without that?
Like for a proof?
Yeah.
If you need it, you have to use it in a proof. But yeah, you can work your way around it.
Okay.
Because you could, so what Hannah's saying is there any way to work around this proof? But and there is, because I can say 2 is complementary to that. And that's what the actual proof of this is. When I prove this, is kind of a workaround if you don't remember this theorem. All right? So the very first thing is prove this theorem is true. We're going to go ahead and prove this theorem is true. So the first thing I'm going to do is I'm going to look at this plan section. We're not going to actually put anything here. This is just to get you thinking on like a test. I have no idea what to fill in here. Just give me a couple sentences of what your plan is to actually do it. Yeah.
Should you do like the thing where it's like put like 2, like after the 2 is congruent to 4, and then for step 2 would be 1 is congruent to 3. Wait, be like 3. Wait, 1 is congruent to 4, and then 2 is congruent to 3, and then be 1 is congruent to 3, and then that would be definition of the congruent.
There's no definition of congruency.
Or definition of supplementary.
We're going to definitely use definition of supplementary, and I think you're on a right path there, but let's just do one step at a time. So my first thing is, let's list our given. Angle 1 and angle 2 are supplementary. And angle 3 and angle 4 are supplementary. There's actually a third given step, right? But just because it's so much different than the other two, I'm just going to bring that in later. All right? I want to say, hey, these two are kind of standalone given. We're going to use it maybe later on. So remember, anytime they tell me something is supplementary, I need to tell what that means. All right? That is always our first step. If they give me a word, I'm going to explain it down here. So down here, I'm going to go ahead and say, well, that means that measure of angle 1 plus measure of angle 2 equals 180. And it also means measure of angle 3 plus measure of angle 4 equals 180 degrees. I'm going to use the angle addition postulate. You could use the definition supplementary too. I just want you to know, I did this without even reading what I needed to prove. Did I even mention what I needed to prove yet? No, I just know how proofs are supposed to go. They go with list this, and if I can unpack it, unpack it. All right? There's no skill in that. It is first step, they give me a definition. Second step, unpack what that definition means. All right, my third step is, well, I can't do much with, I could put this on the other side, right? Because I do know I need to get 1 and 3 on opposite sides. Do we see that? So let's just go ahead and put them on opposite sides. There's multiple different orders to do this. I'm going to kind of run out of room, so I might shift stuff around. But let's just say my third step, and you could do this completely different. Let's just say my third step is to get 1 and 3 on opposite sides. And the only way to do that is to replace one of my 180s or substitution. And that is substitution. Yeah, great.
Also do like measure, since measuring of, oh, what am I getting? I'm maybe we're getting to that step, I'm not sure. Like I was thinking when measuring angle 2, since measuring angle 2 equals measuring angle 1, it has to equal, measuring angle 1 has to equal measuring angle 2.
Kind of like that. What I'm going to look at right now is I have them on opposite sides. Now, if I could get rid of this 2, and I could get rid of this 4, I'd be left with 1 and 3 on either side. Well, the only way I can subtract something from both sides is if it equals the same thing. So at this point, I'm going to say, is there any way to prove that angle 2 and angle 4 are the same size? Oh, the given. So this is where I bring my given back in. So let's do 4. And this is where we could do a couple different things. So I'm going to say measure of angle 2 equals measure of angle 4. So there's two paths we can take. One is a little more correct, and one is just a little quicker and makes the same amount of sense. The long route would be take this measure of angle 4 and plug it in for measure of angle 4 here. And then we'd say reflexive property says measure of angle 4 equals measure of angle 4, and we subtract stuff. The much shorter way is I'm going to jump straight to step 5, and I'm going to say measure of angle 1 equals measure of angle 3. Yes?
Substitution.
Not substitution. First I should list my given. We know it's not substitution because something's actually disappearing from here. All right, something's disappearing. How can something just disappear? Yeah.
Subtraction.
Subtraction. Subtraction, property of equality. Because I'd be subtracting 2 from this side and 4 from this side, and I can do that because I said they were both equal. It's okay to subtract the same thing from both sides, and that's in fact what I'm doing. Sabrina, I just want to make sure you're clear. Do you understand why it's subtraction?
Not really, because there was no measure of angle 1 and measure of angle 3 before. Oh,
It's right here.
but what about step 4?
Step 4 is so I can subtract out these two things.
Oh.
Because I have to show that they're equal so I can pull them away from both sides.
Oh.
Okay? So as soon as I prove they're equal, I can now eliminate this, throw it away, eliminate this, throw it away, because I'm subtracting it from both sides. Okay? Yep. If anything's ever being reduced, it's usually subtraction, not substitution. All right, we got another proof, because why not, right? I'm not even going to read this proof. I'm just going to go on autopilot, and I want you guys to do the first 2 steps. Do the first 2 steps in this proof. Doesn't require knowing what I'm proving. All right, I want you to do the first 2 steps. It doesn't require even knowing what to prove. I'll be doing it along with you. I'm going to try writing smaller so I have more room. Yeah. Remember, you're missing stuff, right? Did you get it? Yeah. Oh, you're going on, aren't you? Ooh. Gotta stay with us if we're doing this stuff, okay? Would you go up? Yep. Okay, it looks like most of us understand what we're supposed to do. We're supposed to say that angle 3 Let's put measure of angle 3 plus measure of angle 1 equals 180 degrees. And we should also say that measure of angle 4 plus measure of angle 2 equals 180 degrees. Either use the definition of supplementary. I'm going to go ahead and just use the angle addition postulate. The reason why I always pick angle addition postulate is because we use it so much. I'm going to just keep using it as much as I can. All right, now might be the first time I look up and see what I actually need to prove. All right, I need to prove that angle 3 is congruent to angle 4, but I have to go through these two things. So I'm going to say, well, I need angle 3 and angle 4 on opposite sides. That's kind of like what we just did, isn't it? I want angle 3 and angle 4 on opposite sides of the equal to sign. How would I do that, Grace?
So you could take the, do this, substitution. So you go measure of angle 3 plus measure of angle 1 equals measure of angle 4 plus measure of angle 2.
Huh. So that's kind of a nice pattern to see, right? I unpack something and set it equal to each other if that happens. Yeah. Sabrina.
Substitution?
That one is for fact substitution. Step 4 is a little bit different. I need to get rid of measure of angle 1 and measure of angle 2. The only way I can do that is if they're equal to each other. Grace, you just answered one.
Sorry.
Who else got one? Robin, how could I say that angle 1 is congruent to angle 2? How do I know that for a fact?
You can try. Yeah.
I just want to know, because if I get rid of measure of angle 1 and measure of angle 2,
Yeah.
I'm good. But they have to be equal.
Yeah.
And I need to look up here. Am I pointing to it?
Your head's
How do I know that those two angles are...
Because they're vertical.
Do that one more time?
They're vertical.
They're vertical angles. I need to, every single time I see a picture of vertical angles, tell myself, I bet you any money, I'm going to use vertical angles. So you need to be on the lookout for this, all right? I can't stress that enough. Be on the lookout for that. So, ooh, ghost. So I'm going to say measure of angle 1 is equal to measure of angle 2. And that's because they are vertical angles. I don't need definition or anything, just say vertical angles. We're going to use that so much that just saying vertical angles, we all know what we're talking about. I'm already on my last step. How'd that happen? How'd that happen? We got 2 people that know how it happened. Can we get some more people that know? All right, 3. Come on, guys. What happened there? What happened there? What happened there? How did I get from here to here? Lydia.
Because 1 and 2 are vertical angles, so 3 and 4 must be vertical angles.
Nope.
No?
Close. I went from here to here. I got rid of my 1. I got rid of my 2. What property lets me get rid of 2 things? Subtraction property. You just went a little in depth there. Even like philosophical. I just needed the. I just needed subtraction. Subtraction, property of equality. Do you all get those? Okay, awesome. All right, what I want you to do. We did these exact ones yesterday, but it's nice to repeat these because you're looking up things. All we're going to do is same thing as yesterday, so don't look back until you have a guess. All right? So did you have an answer?
Yeah, well, I have a question.
Oh, okay, yeah.
Number 4, XB isn't like array, because it's in a different...
Oh, it should be XZ,
Oh.
XZ, XZ, XZ. I think I had a copy and paste issue there. It should be XZ, XZ,
So hard to say.
XZ. In fact, what time are we done at? Maybe we'll just go through this real quick together. We're done in 5 minutes. Let's just do this quick together. All right, it says angle 6 is complementary to angle 10. Angle 7 is complementary to angle 10. I'm supposed to come up with two angles that are congruent in that statement. What two angles are congruent in that statement, Hannah?
6 and 7.
6 and 7. Angle 6 is congruent to angle 7. Do we have a proof, a postulate, a theorem, a definition, or something that says complementary to a complementary is congruent?
Definition of complementary angle?
Close. Close. We have a better one.
Theorem 2-8.
Theorem 2.8. If you don't know Theorem 2.8, open up your theorem guide and look at it. Because Theorem 2.8 is what we just covered. And that's, if you ever see two complementary things in a statement and they're asking for a proof, it is probably Theorem 2.8. Likewise, if these would have said supplementary to each other, you would have said 2.7. All right, measure of angle 5 is equal to 31. Measure of angle 7 equals 31. I would accept two. I would accept two possibilities for this one. Does anyone want to take a shot at this one? One person is willing to go out on a limb. First of all, I'm going to say that measure of angle 5 must equal measure of angle 7. I think I would accept two of them. All right, Abby, can you give me one reason why this might be true?
Well, it's the same measure, so they have to be equal. I
Yep.
don't know what the technical definition of that is.
That would be the definition of congruent angles. Yes. You might have also, I'd have been okay with reflexive property. And I think there's a couple more I would have accepted in that one. Not reflexive, transitive. Because you would say measure of angle 5 equals that, measure of angle 7 equals that, 31 equals 31. So I can use, bless you. You're welcome. All right, AB, you have a question or an answer?
I have the answer.
Okay, first, AB is perpendicular to CD. What two angles are congruent then? Amber?
Oh,
Ooh.
sorry.
Oh, too bad.
8 and 9.
8, 9, yeah. Angle 8 is congruent to angle 9. And Sabrina says she's got the theorem that says it.
Theorem 2.4.
Theorem 2.4. Do we agree on that?
Yes.
We're good? Okay. Theorem 2.4. If you're very unsure of it, look it up. Yeah. Yeah.
Wouldn't that also be the definition of the perpendicular line?
I'd probably be okay with that.
Okay. And then if we wrote like ABC equals 90 and ABD equals 90, would that work too as the conclusion?
Are they the same angles?
Yes.
Is
Oh, so it's
ABD
just like one
angle 8?
page. Okay.
Yeah. Yeah. We're good. Yeah.
Well, for 2, what was the other? It was definition of congruent angles or reflex.
Transitive.
Transitive?
There's also a postulate or something in there that might work. All right, the last one says angle or line XZ. Lydia?
Measure of angle WXZ is congruent to measure of angle X or ZXY.
Yep. I'm going to call it angle 6 and angle 7. I'm lazy. And that's just going to be definition of an angle bisector.
Say like bisector theorem.
There is one, but if you remember, the bisector theorem talks specifically about things being half. The bisector theorem says basically if this bisects it, this will be half the total angle and this will be half the total. So you're looking out for 1/2 to use that one. All right, everyone. Test. We have a test next Wednesday. Monday isn't gonna, no, I was waving at someone at the door.
Oh.
Wednesday isn't brand new material. It's just gonna be more proof work from the same section, and then I'll hand the review to you out on Monday. Wednesday, hopefully you have some of it done so you can ask questions. We work on it Wednesday or Tuesday, and then we take the test Wednesday. We all get perfect scores, and we move on to the next chapter.